Okay, I'm back to 52 weeks of AWS, and I've covered a lot of certifications from the cloud practitioner to solutions architect to AWS developer to AWS machine learning. Now I'm going to cover the security certification. And if you click on this link, this is in the Noah Gift AWS Bootcamp section here. I have some slides for security. And this is one of the things that's kind of fun in evangelizing AWS is to talk about some of their certifications. And in particular, I think security is maybe the most important topic to be an expert at. But I'm going to go ahead and get right into this thing and talk a little bit about it. So, this particular session, I'm going to talk about the cloud security foundations here. And the idea here is that when you're done with it, you'll be able to prepare for the AWS certified security specialty certification. And some of the things that you should be aware of would be it is a good idea to do AWS Academy Cloud Foundations. You should know about distributed systems, a really important topic for machine learning as well. You should know about general networking. You should also know about multi-tier architectures and know about cloud computing. And then at the end, you should be able to identify security benefits and responsibilities for AWS, know about identity and access management, also describe the secure network access for AWS, explain available methods for encrypting data at rest and in transit, and then also know about different AWS services that can be used for monitoring and incident response. So the outline will be as follows. So I'll see how many I can get per week, but it'll be in module 1, welcome. Next up, introduction to security on AWS. Module 3 will be securing access to cloud resources. Module 4 is securing your infrastructure. Module 5 is protecting data in your application. Module 6 is logging and monitoring. Module 7 is responding to and managing an incident. And then finally, the last one, like a typical certification course, would be bridging to certification. So inside of this as well, some of the things to be aware of it would be to know how to do shared responsibility model, reading log files, etc. So that's kind of it for the first module here. I'm going to go into the second module now. And again, you can just click on these slides if you want to take a look at them yourself by going to the link that I shared earlier. But let's get right into the details of really the meat of the first lesson, which is Introduction to Security on AWS. The idea is that you should be able to understand the different security features of cloud computing, understand the security principles that AWS Cloud is structured around, and then also identify what part of an application the user is responsible to secure in the cloud. All right, let's go ahead and take a look at a bank scenario here. So what would you need to do to secure a bank? So one of the things you could really talk about is, let's say you're presenting the security to the bank. A good way to actually go through this is to think about it from a scenario-based perspective. So, you're gonna maybe explain to the bank that there's a shared responsibility model, and the customer has a responsibility alongside of AWS. And I think that's one of the more important concepts in security is the shared responsibility model, that the business logic is your responsibility, but certain layers of the hardware, the networking, the physical data center are responsibilities for AWS. So let's go ahead and dive right into it. What are the benefits of cloud computing? This is really a classic slide, I think, for many people taking certifications, is you have to know about the fact that you're trading a fixed expense for a variable cost. You also are going to benefit from massive economies of scale. You're going to stop guessing capacity needs. You're going to increase speed and agility. You're not going to spend money to run and maintain a data center, and you're going to go global in minutes, right? These are really the core competencies of cloud computing. Now, in terms of security, a few things to be aware of is that there are different ways to think about protecting intellectual property from unauthorized access. And one of them is confidentiality. So, limiting access and disclosure to authorized users would be a good example. Also, preventing access by unauthorized users. And this is, I think, one of the issues that's has really been a problem in America in particular, is that there has been a lack of confidentiality for many organizations because they haven't designed things in a way that is going to prevent that. Also, integrity is one that's kind of surprising in a way, but it's that you're going to maintain the data consistency. So, like, has someone corrupted the data? Did they, go in and change some records? Also, is the data preserved at rest, and is it preserved in transit, right? So that's the encryption components of it. And then in terms of availability, if somebody hacked into your system and encrypted all your data with their encryption key, then it's not available to you. So availability is the readiness of the resource system. So these are all big challenges in the current world that we face in terms of security. Now, in terms of the AWS cloud security, some of the objectives would be controllability, audibility, visibility, agility, and automation. So what this means is that the security in the cloud is similar to on-prem data center, but you don't have to have the cost and complexities of it. Instead, you want to make security by using AWS familiar with way a physical data center would be treated. And there's actually several tools that will allow you to treat things that way. So in terms of AWS cloud security or controllability, a few different things to be aware of are there are methods and tools to manage access controls for users, groups, and roles. And you can even do temporary security credentials and control encryption keys. There's also IAM management service that allows you to deal with granular level permissions. You can also grant permissions to different people for different resources. So you can have users complete EC2 or S3, etc. You can also use the AWS Security Token Service or AWS STS to create a trusted user with a temporary security credential. So one of the things that's nice about a temporary credential is that it does solve one of the stickier problems, which is what happens if there's some outage or leak or whatever. Well, if someone stole your temporary credentials and they're limited in scope to what they can do, it really, in a sense, the problem solves itself, right? If they can only read from some restricted resource and then eventually the key expires anyway, there's only a small window to the damage. But if you have a unlimited key, then really the sky's the limit. And there's also AWS Cloud HSM, which protects encryption keys with a hardware security model. So in terms of audibility, a few different things to be aware of is, who has access to this resource, like who are the people inside, right? This is a critical one. Are you looking at the log files to see what's going on your system? Also, who performed what action? So why is maybe a person that shouldn't be looking at payroll data looking at payroll data, right? Like that's a critical question. And then finally, like how often is someone performing the action and from where? So like if someone is doing something accidental, maybe they only did it once, but if they're repeatedly doing something that looks unusual, and then also it's coming from maybe a different country where the rest of the employees in your organization work, that could be a problem. And then what's the evidence? And so this is where really the audibility is a critical component of security. And then in terms of visibility, I think it's important to know, like, what are the resources that are in your environment? What are the servers, the storage, and then what is the impact that a particular action would have, right? So if there is an outage, for example, what would happen? What's changed? And this is another big one that is kind of a classic problem with security, is what has changed from the last time I looked at the system. And again, what's the evidence? Things like AWS config is a good resource that can go through and audit all changes that have occurred on your system. And then in terms of agility and automation, so how do I ensure high availability? This is a big one. Automatically scaling to ensure high availability is one way to solve a particular kind of problem, right? So if someone's doing some type of resource attack, then also kind of automatically deploy applications with security and compliance. So if you're manually applying security best policies, it's going to be easy to make a mistake. And then also, how can I apply a security check in a reproducible manner? So this is another one. If you're not um, automating security, then how do you know that the security has actually been implemented? So some of the big takeaways here is that confidentiality, integrity, availability. These are some of the key things to be aware of. And AWS has many tools that help you do things like control access to resources, audit what's happening, look at visibility, look at agility, and look at automation. All right, now let's talk about security design principles. So in terms of introduction to security on AWS, this is the big one that I think many people don't do that seems simple but is important, is the principle of least privilege. So you grant the access as you need it. So it's really a heuristic. So what you do is you say, I'm going to build something, but I only will build something with the limited resources that this particular service needs. And this enforces separation of duties so that if it was compromised, you're only compromised for that one part. And as well, if you can avoid long-term credentials, this is a critical one. So a few different things to think about would be, organizing security culture built on this principle, deny everything unless someone needs it based on a job role, reducing or even ending long-term credentials is a great strategy. Using the identity and access management as a key part of information security program. And then also you can define principles, basically accounts that can perform actions. So this is a lot of times one of the ways that you can control things is to apply a role to a service like AWS Lambda, and then there's no keys that are floating around that can be compromised. In terms of enabling traceability, this would be looking at the logs and metrics, auditing your resources, and then monitoring the actions. And with CloudWatch in particular, and CloudTrail, these are both two tools that you can use. And the CloudTrail is the one that will log what is the user account and what's the API that's being used. And so from just a one place to look at initially, if you have a security issue, a security event, the CloudTrail would be the first place to look at. But also CloudWatch is good because it actually gives you visibility into the entire AWS ecosystem. And then in terms of securing all the layers, a few different things to be aware of are, using a defense in-depth approach. And so what this means is that you apply security to every layer, right? So you're not just applying security at the front door, you're doing security at every single part, the network, the application, the data store. What's nice about this is that you're continuously causing security strengths so that if there is a weakness in one part, you can only go so far. And this is one of the benefits of using this layered approach to security. And then also one of the things you can do is you can use higher level services that have a more of a hardened, ecosystem. So for example, if you're using, Elastic Container Service, well, the whole image itself is on the container. If you're using a platform as a service, for example, you're actually protecting a lot of your services. So the more higher level of a service you use, it does actually give you a layer of protection. And then automating security, I think this is a big one, is that in general, a good approach to DevOps is to say, if it's not automated, it's broken. Same with security. If you're manually applying some kind of security routine like firewall rules, etc., you're going to cause problems because somebody will forget to do it, and then that's going to leave a vulnerability open. And so automating security is really not an option, it's a requirement. And one of the ways to do this is with infrastructure as code. So basically defining the way your infrastructure works. And then every time you make a change inside of your project, the infrastructure is checked. And so your infrastructure becomes idempotent. What that means is that there's an action that occurs and it always maintains the state of your infrastructure. Another one that's a really big one is this concept of protecting your data in transit and the data at rest. So, for example, using encryption, access controls, you know, if you're not protecting your data consistently in the transit and also at rest, one of the issues is that even though it seems like it would be maybe a far-fetched scenario that someone could break into your system, if they did break into your system and your data is fully encrypted, there's nothing they can do with it. Right. So that's really part of the layered security concept. Also, it's important to classify your data with tags. And so then you understand what sections of data are potentially more critical and have maybe even higher security requirements, like a particular S3 bucket that was tagged could make sure that there's no personally identifiable information in it, for example. And then also using VPN and TLS connections so that you're applying yet one more network layer of security. And then also being prepared for a security event. And so if you do expect a security problem to occur, one of the things you can do is actually have a strategy in place already. So some of the things you can do for an incident response would be make sure that you have detailed logging available. You could make sure that the events are automatically processed and invoke tools in response. And you can also pre-provision tooling in a clean room by using AWS CloudFormation to carry out maybe a forensic task in an isolated environment that you're worried about. So I think this is a mature way to handle security, is to say that you're going to assume someday there will be a security incident and you're already preparing for that event. And then minimizing the attack area. So in general, an attack would be able to be shut down for a couple different reasons. One of them is that the attacker just gives up. And the other one is that they achieve their goal. Obviously, achieving their goal is not a good strategy for you. So one of the ways you can mitigate this is to reduce your exposure to unintended access by making sure things like the operating system, the components, the libraries are all hardened, ensuring that they have the latest updates, making sure that the security groups and network access control lists are robust. And so the idea here again is to reduce the attack surface area. There's also tools that can prevent attacks with AWS. For example, a common infrastructure layer attack like UDP can be handled by CloudFront. A SIN attack is a flood type of DDoS attack that can be handled by AWS Autoscaling, CloudFront. So some of these techniques are only valid if you don't have this ecosystem in front and you're not using tools like CloudFront. So some of the key takeaways here to summarize would be principle of least privilege, traceability, secure all the layers, make sure security is automated, protect your data, at transit and rest, and assume that there's going to be a security event and know what you're going to do about it, and then minimize the attack area. So let's talk a little bit about shared security model next here, which is pretty common that many people don't know about it, even though they use AWS. So the key thing is that you're going to have a partnership with AWS, and AWS is responsible for some of the things. So for example, in terms of AWS compute, storage, database, networking, these are all physical hardware, global infrastructure that AWS is going to take care of. But then in terms of what you do, the customer data is your responsibility. You also have to make sure you're selecting the right EC2 instances, handling the configuration of security groups, firewall configuration, networking. So AWS, it really does tackle hardware, software, and network, but then you have to implement it in the right way. And that's the shared responsibility model. So a good example would be if a company uses S3 to store data, the AWS environment could include EC2, it could include RDS, all of these resources. And so on the physical layer, they're able to control it, but the customer is responsible for managing the guest OS that runs in EC2. They're also responsible for managing the updates, and they're also responsible for the configuration. of the S3 buckets. Now, in terms of the security in the cloud, one of the things to be aware of is that AWS would secure and maintain the cloud infrastructure, but you're responsible for everything you put in the cloud, right? So the cloud itself could be secure, but it depends on how you put things inside of the cloud. So the content you choose to store on AWS, the services that interact with the content, the country that is involved with the content stored, the format and structure of the content. Is it encrypted? Is it anonymized? Is it masked? And then who can access the content, right? If you expose your content as a public bucket, then you've exposed your data. There's nothing AWS can do to prevent you giving people access that they shouldn't have to your data. Now, in terms of the shared responsibility model, some of the things you could do is you could look at a diagram like this, for example, and ask yourself some questions like, who's responsible for what. You could also look at maybe a key SSH key scenario again, kind of ask yourself the questions around who's responsible for what. I think it's not a bad strategy. Now, in terms of managed services, a few different things to think about would be you could actually have a managed services organization. So you could have a centralized team that's responsible for establishing a repeated process. And one of the ways you could do this would be, you could have a pull request, right? Can you approve my new CloudFormation template? I need a new development environment. We need a new account for billing. We need 5 new IAM users. Which approved IAM is the most recent? So you actually can have some centralized security that could significantly improve what's going on. Now, in terms of the MSO model, this is where the workload owners would handle the actual deployment. And in terms of this model, you can ensure that the applications are deployed in a secure manner. And after reviewing workload use cases, you could establish, initial accounts. You could have, security oversight. So really, the idea is you're just enhancing the traditional example here of having the shared security model. So some of the key takeaways is that AWS again will help people achieve security, but the customers are responsible for what goes in the cloud. So you could develop an MSO which provides some guardrails. All right, so really to wrap things up, we talked about security features, benefits of cloud computing. We identified the key security principles for AWS, and we identified what parts of an application the user is responsible to store in the cloud. And you could go through and look at some exam questions after that. So really, in a nutshell, that's a pretty good, I think, first start to dealing with security. We're going to cover. It'll be a couple weeks from now. I'll dive into the next section. But thanks for hanging in there, and see you in a couple weeks.